And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of Read Code and Geeks for Geeks. So without wasting any time, let's get started. Today's problem is tree order traversal, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given just one root node of a binary tree and we have to return the boundary traversal of this binary tree. Now you will be thinking, what is this boundary traversal? Yet every day a new traversal comes. Okay, so let's see what boundary traversal is. Basically, left boundary, like taking all the nodes of the left subtree, and after that the leaf nodes is basically these 8 9 4 8 9 6 7. These are the leaf nodes, and after that the right subtree, right boundary. So this includes all the nodes on the path from the rightmost leaf node to the root, traversed in reverse order. Okay, so this is what we have to do, traverse in reverse order, and you must prefer the right child over the left child while traversing. I will explain all these things with the help of few examples. So this is what the problem is. If you will see this binary tree, if I try to explain you with one example, so if you can see this example 1 2 4, um, 1 2 4 1 2 3 4 5 6 7 8 9. Okay, so what is the boundary traversal? First of all, cover all the left nodes. Okay, after that cover all the leaf nodes, and after that cover all the right side nodes. So right side node is only 3 because 7 is already covered and 1 was already covered. Okay, so this is what is the boundary traversal. This element 2 4, then 8 9 6 7 3. Okay, so the same thing is drawn here as well. We will see 1 1 to 2 2 to 4 4 to 8 8 to 9 8 9 to 6 6 to 7 7 to 3. And also if you will see here, it's reverse right order. Like basically traversal should be in form of following order: left order, then leaf nodes, and leaf nodes should be that leaf nodes which are not covered in left boundary or right boundary, and after that reverse right boundary. Basically reverse right boundary means from bottom to up, from bottom to up. Okay, so if you will see this example, so right boundary will be in this direction, like 7 then 3 then 1. Okay, so 1 is already taken. In this way we have to simply return the boundary traversal. I hope the problem statement will be a bit clear to you, but if we will see one last note line, if the root does not have a left subtree or right subtree, then the root itself is the left or right boundary. Okay, all right, what does this line mean? Please read it once more. um, if the root does not have a left or right subtree, then the root itself is the left and right subtree. Okay, so if you will see this example, if you will see this binary tree, here there is no right subtree, there is no right subtree, which is null. So in that way, what will be our boundary traversal? Let's quickly see. First of all, the left nodes, all the left nodes, 1 2 4. Okay, after that the leaf nodes, which is 6 5 7 8. After that the right nodes. So right boundary, if you can see, this is my right boundary 3 9 2, but I will not include them. Why? Because here the right subtree is null. In that way, in that case, this 1, it will act as the right subtree full. So our answer will be 1, 2, 4, 6, 5, 7, 8. That's it. I'm not going to include these because its right subtree is null. So right subtree is only this root node, not these elements, Okay. So yeah, this will be our example. I hope it will be very, very clear to you. So the problem statement will be clear to you now. And now let's think of the approaches which we are going to take one by one. And for that, let's move on to the note section. Okay, all right. So this is our first uh, test case, first example. Let's say 1 2 3 4 5 6 7 8 9. Okay, what I'm going to do, I'm going to make three functions. First one will traverse all the left nodes. Okay, second function, first will take all the left node. Second will take what? Second will take the leaf nodes. And after that, the third one, what third one will do? Third one will basically reverse right nodes. Reverse right node. So this is what I'm going to do. Okay. So now if you will see here, 4 will come in left nodes as well, left side, and it will also come in leaf node because 4 is also leaf node. Similarly for 7, it will come in leaf node and also in reverse right nodes, something like this. So we have to take them only once. So what step are we going to do? We are in left and right, in left and reverse right, we are going to only take those nodes which are not leaf. Here I'm going to take only those nodes which are not leaf. Okay, all right, very simple it is. So what how I'm going to write the left function, let's quickly see. So basically, just give me a second. Okay, so in the left function I'm going to start, first of all I will add 1. I will add 1 to my answer. Okay, 1 is added to my answer. If it is not leaf node, 1 is added. Okay, all right. After that, what I'm going to do, I'm going to check key. Now 2, look, 1 is added. So now I will pass the left function. I will pass the root dot left, which is 2. 2 node. Okay, all right. Now should I include 2 to our answer or not? Look, it depends on one condition. If at any point if this 2 is leaf node, I will not take them because leaf node will be covered in second part. But if it is not leaf node, I will take it. Okay, so 2 is not a leaf node. It has children 4 and 5. 4, so it is not leaf. I will take 2. Okay. After that, if 2 dot left is there, so take it. Otherwise, if 2 dot right is there, take it. Okay. Now I come to 4. I come to 4. So will I take 4? Is 4 a root node? 4 a leaf node? Yes, 4 is a leaf node. I will not take 4. And that's it. The left subtree is done. Left subtree is done. Okay. Now let's take the leaf node. So for leaf node, again, I'm going to use this node. And now I'm going to take in order traversal. In order basically means left side, root, and then right side. Okay. So left side, first of all, left subtree 2, and for again this 2, left subtree, which is 4. So I'm going to take 4. Now why did I not take 2? Because whenever in order function I will get any element, I will only add to my answer array list when it is a leaf node. So 4 is a leaf node, 4 is added. After that, 8 9 are leaf nodes, so 8 9 are added. After that, 7 is a leaf node, so 7 is added. 6 is also a leaf node, so 6 added, and then 7 added. Okay, all right. Now after that, this leaf node is also done using in order traversal. Very easy it is to include leaf node. After that, I'm going to take reverse right. Okay, so look, to add, yeah, to add in, let's suppose in starting order, and then in reverse node I have to take add in the reverse order. Very simple. First thing first, uh, first one, look, I will be given this 3 on node only, because I will not be given other nodes, because look, 1 is already included, so I will not pass 1. Now only 3 is there, like third 3 node is there, so I will include 3. Now, look, for this example, I think only one node is there. So let's write 3 and we are done. So I think left subtree and leaf node, how are we going to add, will be very clear to you. Now let's think about reverse right. So I want to take that example where there is reverse right. No, there is no reverse right here. Let's include one more, 10. And let's include one more, which is 14. So this is something our uh, tree, and we have to write the boundary traversal. First of all, 1 will be added. Okay. After that, left subtree. Look, now 2 is there. Okay. But two's left is not there. Two's left is not there, but right is there. So now I will say something ki yeah, 2 is included. Again, call this left function. Again, call this left function. But this time for the 2 dot right. Okay. So 5 will be taken. Will 5 be included? Yes, 5 will be included. Why? Because 5 is not leaf node. So 5 is added. After that, will 9 will be included? No, 9 will not be included in this left function because it is leaf node. Okay, then after that, left, all the left nodes are done. So after that, root node chance, leaf node chance. So 9 is a leaf node, 6 is a leaf node, and after that 14 is a leaf node as well. Okay, all right, so let's add them. 9 is added, 6 is added, and 14 is added as well. Okay, after that the reverse right, something like this. So here 14 will not be included because 14 is a leaf node. Okay, after that what I'm going to do, basically I am currently at root node. Okay, I'm currently at root is already taken. I'm currently at 3 root dot right. Okay, I'm currently at root dot right. Okay, what elements I'm going to take, let's see them. First of all, um, let's suppose 10 instead of 14 to the right, 14 is here. Okay, something like this. No issue is there. So what I'm going to take, I'm going to check if 3, if 3 is basically um, like 3 is a leaf node. No, 3 is not leaf node. I'm going to add 3. But before that, I'm going to recursively call this function again. Like first of all, include all the elements, all the down elements, then add 3. In the leaf, in the left, I'm going to do what? Is to a leaf node? No. So add it and then recursively call again. But here I'm going to call again recursively, and when coming back from that function, I'm going to add 3. Okay, all right. So recursively calling 3 is still not added. This is still in that call stack, and now I'm calling 7. Okay, so now 7 is a leaf node. No. Okay, I will not still call 7. I will 14 is removed from here. I will still not call 7. I will call its next element. Next element is 10. Okay, so 10 is leaf node. No. Okay, so 10 will not be added. Now 14, I come to 14. 14 is a leaf node. Yes, 14 is a leaf node. Okay, so we are not going to do anything, and now I'm going to roll back. So now after rolling back, I come to 10. Let's quickly add 10. After that, I quickly roll back again to 7. So now let's quickly add 7. And after that, I quickly come to 3. So let's add 3. So this is the in order boundary traversal of our given binary tree. I hope it will be very, very clear to you now how are we going to approach this. But when I'm going to write the code, it will be crystal clear to you. Like absolutely clear. Okay. But before that, can you guess me the time and space complexity, guys? Look, time complexity is very, very simple. At most, I'm going to traverse all the nodes. Maybe I'm going to traverse all the nodes 3 times, but it is still linear because 3 into number of nodes, which is n, is equal to 3. But it will not be 3n, so basically it will be n because we only take the variables. So n, time complexity is done. Space complexity. Space complexity will be what? Space complexity. First of all, I'm going to take all the boundary elements. So in the worst case, boundary elements will be equal to all the node element, because for something like this, let's suppose this is a binary tree. It is a binary tree. Now for this, the boundary order traversal will include all the elements. So it will be basically big O of all the nodes. But ideally, what I'm going to take, I'm not going to include that in space complexity because that is what we have to return. Now, in recursively, we are using some call stack. Now, in that call stack, what happens? What is the height of binary tree? Maximum height of binary tree, that will be my space complexity, because for this 14, I'm going to have 10 in my call stack. I'm going to have 7 in my call stack. I'm going to have 3 in my call stack. I'm going to have 1 in my call stack. Not 1, but 3, 7, 10, 14, which is the height of binary tree. Okay, so height of binary tree is the space complexity. I hope the time and space complexity will be very, very clear to you now. Let's quickly move on to the code section where I'm going to write the code and you will get it. Okay. All right. But before that, if you have loved the explanation till this point, I will request you guys to please subscribe the channel and like the video, because I'm giving my full effort and I'm not getting that much subscription and likes, comments. So please comment down, subscribe the channel, like the video, and now let's quickly see the code. Okay, first of all, I'm going to have an answer array list which will be of type answer, which will be of type integer. And if you code in C++, no issue in there. I will add C++ link as well to my GitHub. Okay, so now one thing I'm going to check, yeah, if can we have a first node as null? How many nodes can be there? No, first node cannot be null. Okay, so let's remove it. Now what I'm going to do, I'm going to first of all call key left tree, left nodes. I'm going to call left nodes, and I'm going to pass my node dot left. Okay, and after that, one more thing, I'm going to pass answer key left nodes, add all the left nodes of this binary tree into my answer. Okay. After that, I will ask call add leaves. Here add leaves, all add all the leaf nodes. So here I'm going to pass the node and answer. Okay. And after that, I'm going to call write reverse nodes and again pass node and answer. Okay. Node dot write because node is already included. Okay, so this is what we have to do, and after adding all these things I will simply return answer. Okay, so very simple till this point. Now we are just have to implement these functions. Let's implement them one by one. First of all, what I'm going to implement left nodes. Okay, so it will be basically not returning anything, so let's write void left nodes, and include it will be taking two things. First one is the node, and second one is basically array list answer. Okay, so look, I'm only going to add this node to my answer array list if it is not leaf. Okay, if it is not leaf. So how I'm going to check? First of all, if is node null. If node is equal to null, I'm not going to do anything and I will simply return. Okay, but if node is not null, now I'm going to check if node dot left not equal to null. Okay, so it means node dot left, currently I'm at 2. Let's suppose if node dot left not equal to null means 4 is not null. What I'm going to do, I'm going to add 2 to my answer. Let's add answer dot add node dot data, and now again I'm going to call this left node left nodes, and this time with the node dot left and answer. Okay, similarly, if let's suppose you can see here you prefer the left child over the right child while traversing. Okay, so if node dot left is null, it means I have to check here if node dot right not null. Any of them is not null, I am going to include node. Okay, so let's write node dot right. Again, I will copy this. So answer dot add node dot data and left nodes may node dot right. Okay, now you will be thinking why I am writing this. So let's quickly move on to one note. Here you can see this thing. You can see this thing. Let's suppose I'm currently at 2. Okay, I'm currently at 2. Now what I'm going to check? I'm going to check if node dot left is equal not is equal to null, but node dot left is equal to null. Again, I am going to check if node dot right not equal to null. Yes, node dot right is not equal to null. It means I will include 2 to my answer, and after that I will move again. I will call the again left function for this 5. Okay, 5 and then again 9, but 9 is root node, so I'm not going to include. In this way, I'm just writing, and this left node function is done. Let's quickly cover the leaf node function as well. Void add leaves, and here I'm going to pass two things. Okay, so it's basically very simple in order traversal. If I will copy this as well, if node is equal to null, simply return. Otherwise, in order traversal, what we do, first of all leave left side, then root, then right side. Do the same things here. Add leaves, and again call this with node dot left comma answer, and after that look add leaves is done, so left all the left subtree is done. Now what I'm going to check if my node dot left is equal to null and node dot right is equal to null, it means it is a leaf node, so simply add it to my answer. Let's copy this line, paste it here. Answer dot add node dot data. Okay, and after that I'm going to again call this add leaves function, this time for the right side, node dot right. Okay, so left node is done, add leave is done. Now right reverse node. Okay, so let me copy this again. I'm going to change the name and I'm going to delete all these things. Okay, right reverse node. So here you can see what I'm doing. Basically I'm going to add my to my answer and then recursively call. But in reversing, what I'm going to do, I'm going to first of all call this and then reverse and then add. First of all, add its children and then I will add this. Okay, so basically one line change will be there. So, and for that, for the right reverse node, also I'm going to do preference for the right child. You must prefer the right child over the left child while traversing. Okay, so let me copy this whole code and then I will change it there only instead of writing it again. So I'm going to do preference to the right and then left. Okay, so just one line change and here left. Okay, now also I have to change the recursively function call name. Now what I'm going to do, I will add later, but recursively call its children first. Okay, so same thing here. And that's it, guys. That is it. Let me try to compile this and I hope it will be running without any silly mistake. Yes, one error is there, which is I am not adding root anywhere. I'm not adding this one anywhere. Okay, why? Because for the left nodes, I'm passing node dot left. For the right node, I'm passing node dot right. And one is not leaf node, so it will not be added here as well. Let's quickly check add root node. But I'm going to add root node only if that is not a leaf node. So I'm going to write something like if node dot left not equal to null or a node dot right not equal to null, it means it is not a leaf node. If it is not a leaf node, simply add answer dot add root which is node dot data. Why I'm checking for the leaf node? Because if it will be a leaf node, it will be covered in add leaves. This one, if it is a leaf node, it will be covered in add leaves. But if it is not covered in add leaves and it is not covered in left node, it is not covered in right side. Why? Because it is not a leaf node. So I will have to add it in the starting. All right, I will, let's directly submit it this time and I hope it will accept it. But if you have loved the explanation till this point, please subscribe the channel, like the video, comment down your views on it. I have already explained the time and space complexity as well. And that was it for today. I'm going to see you again tomorrow. Till then, keep on coding, subscribe the channel, and bye.